In this problem, we're going to find V0 of t for t greater than 0 using the step-by-step method. We're going to utilize the problem-solving strategy entitled Using the Step-by-Step Approach. We have a first-order circuit. We've got a single capacitor. We're going to open the switch, and we want to calculate the voltage V0 of t from our problem-solving strategy. Step 1 is we know the form of the solution is V0 of t is equal to K1 plus K2 e to the minus t over tau. And our task then is to use our problem-solving strategy to find values for K1, K2, and tau. The next step in our strategy says draw the circuit at t equals 0 minus, and we want to calculate the value of the capacitor voltage at 0 minus, because we know what's going to happen is the capacitor voltage is going to remain the same, 0 minus 0 plus, or continuity of voltage for the capacitor. So here's our circuit. We've assumed steady state, so we replace the capacitor with an open. So we know, for instance, the current here is 0. Now we need to find that voltage. For instance, here we may as well use mesh analysis. So I'm going to define two mesh currents, I1 and I2. And now let's write mesh equations. So for this top mesh, for instance, we'll have 12K I1 minus 2K I2 is equal to 24. And for our second mesh down here, we'll have minus 2K I1 plus 12K I2 equals minus 12. Now if we solve for I1 and I2, we get I1 is 1.89 milliamps and I2 is minus 0.686 milliamps. Now we want to calculate the voltage VC0 minus. We need to do KVL around this loop. So if we start off, for instance, we know the voltage here is going to be 0. So if we start, we'll have VC0 minus is equal to 0. Coming around, we have 6K I1, that's the voltage here, plus 6K times I2 plus 12. And if we plug in the values for I1 and I2, we get V0 minus is 19.22 volts. So that completes step 2. Now step 3, we're going to draw the circuit at t equals 0 plus. We're going to replace the capacitor with a voltage source equal to the value at 0 minus. So here's our circuit at t equals 0 plus. Notice we've replaced our capacitor here with a source equal to the VC0 minus value, 19.22. Now we want to solve for V0 of 0 plus. And again, we can use mesh analysis. I'm going to call that one I4 and this one I3. And now if we apply mesh analysis, we'll have minus 6K I3 plus 12K I4 is equal to 12. Okay, that's the equation for this mesh. Now for this mesh, we'll wind up with 15K I3 minus 6K I4 is equal to 7.22. So here's for mesh 4, here's for mesh 3. If we solve, we get I3 is 1.1 milliamp, and I4 is 1.55 milliamps. Now if we look at our circuit, V0 of 0 plus then is minus 3K times I3. So then that gives us V0 of 0 plus minus 3.3 volts. So that completes step 3 of our process. Now for our next step says draw the circuit at t equal infinity. Assume that the capacitor is once again reached steady state, so we can place it with an open. So now if we look, there's 0 current, so then that tells us that this voltage is 0. And that's all the analysis we're required to do. Now we can move to step 5, which says find the time constant, and we're going to find the Thevenin resistance as seen by the capacitor, because remember the time constant here is R Thevenin C. So now we need to find that Thevenin resistance. Our voltage source we turn to 0, so it becomes a short circuit. And now it's just a matter of doing some resistance combinations. For instance, we have those two in series, so they would become a 6K. So we could redraw our circuit then. Look like this. And these two in parallel, they would be a 3K. So then R Thevenin turns out would be 3K plus 6K plus 3K, or 12 kiloohms. So then our time constant is R Thevenin C, so we have 12K times 5 microfarads, which gives us 0.06 seconds. Now we're ready for step 6. We know our solution is of this form, so now we just plug in. So V0 of infinity is 0, and V0 of 0 plus is minus 3.33. So then V0 of t is minus 3.33 e to the minus t divided by 0.06 volts. And if we plotted that, here's what V0 of t would look like. The voltage would come along, and switch would move, it would jump to minus 3.33, and then it would decay exponentially down to 0.